As we look at moving forward, we're going to keep working on roots. Yesterday, we spent a lot of time talking about perfect square roots, perfect roots. We do have a symbol to represent roots, and that is our checkmark division sign that looks just like this. Specifically, when you see this symbol, we're going to talk about a specific square root, but there are also other types of roots we'll discuss later called cube roots, which would be doing the same thing, but now finding three factors that are the same number that can be multiplied together to equal the number. But we'll discuss that at a later time. Right now, we're really going to focus on square roots. And when you see this symbol here, the yellow one, that's indicative of a square root. You'll never really see this number 2 in there, only because this yellow symbol means square root to begin with, but just know we can put other numbers there to kind of increase this kind of meaning of this symbol. So when we mention roots, the first and primary one is a square root, but there could be others as well. For the rest of this video, I'm just going to talk about square roots and just keep the symbol like this without putting a number 2. Before we get further, you do have this document that's a companion note-taking sheet. So you can type answers into this document. This is posted in Canvas. You can handwrite them here, but then I'm going to give you some book assignment problems, and then whenever you complete those book assignment problems, if you could take a picture of your problems and then put that picture down at the bottom of that page, this entire thing is what you're going to submit then into Canvas today. So you're going to put in your answers for these different note sections and a picture of your work down at the bottom. So that's what you're going to submit today. I'm going to go through answers to these 5 things. Whenever you think you come across an answer to one of those 5, pause the video, jot down your idea, think about how you can say that in the English language rather than always working in math language, and then we'll keep moving forward. So just remember, this is posted in Canvas, and make sure that you're filling in these answers according to this video. Here's a reminder of where we talked yesterday. In case you missed that discussion, we talked about perfect squares. If you think about a multiplication chart, those perfect squares are those numbers that kind of fall right in the center, kind of down the center line. And that's really the idea that any of these numbers is a perfect square because it has the exact same factors to equal that number. So 6 times 6 is 36, meaning if I take the square root of 36, I'm looking for what number multiplied by itself equals 36. Well, that answer is 6, and they're perfect squares because every single one of these yellow numbers has a square root that's a whole number. So the square root of 81 is 9, the square root of 144 is 12. Whenever we are looking at these perfect squares, and these are ones we're going to get really, really comfortable and familiar with, these are the ones that we want to have memorized because we know the square roots are whole numbers. So knowing that 12 times 12 is 144, 9 times 9 is 81, 4 times 4, or 4 squared, equals 16. That was tough to see. Or the square root of 16 equals 4, kind of going reversed. So knowing that we have all of these yellow numbers to be perfect squares. Here's one reminder of those perfect squares. We have the square root of 64, and that equals 8. And that justification comes from this idea that 8 times 8 equals 64. So the square root is saying what number times itself equals 64. So another way to say it is we could look for x squared equals 64. What number does x have to be that when I square it, it equals 64? That's another way, and we're going to look at this form a little bit later. However, this yellow answer, and this is going to be your answer for number 1, this yellow answer up top is not the only solution. So, but also, the square root of 64 can equal negative 8. Because what we know about negatives is that negative 8 squared is the same as negative 8 times negative 8. Two negatives multiplied together, so bad things happen to bad people, is good. That would give me an answer of positive 64. So I'm still getting the same number as I was up top, even though my answer is negative. So for your answer in the first one, why are there 2 answers to every square root problem? Well, it's because every negative times itself always equals positive. So therefore, we kind of put an answer, and we'll typically see this symbol. The square root of 64 is not just 8, it's also negative 8. So you're going to start to see this symbol to say that both positive and negative 8 are solutions. And that comes down to the idea that, yes, 8 times 8 is 64, but also negative 8 times negative 8 is 64. So really an answer to number 1 could be something like because two negatives always equal a positive. That could be something why that we'd always have two answers, because we know positive times positive is positive, but we also know negative times negative gives us a positive number. So there are also square root problems that will give you things called impossible answers. These are also referred to in other math circles as null sets. Null sets have the symbol of a 0 with a slash through it. So if you ever come across a problem that has a null set, meaning it's an impossible answer, that sometimes happens with square roots. And going back to that previous fact, if I gave you a problem that looked like this, the square root of negative 49, this would be a null set answer, because there is no way we could take a number, multiply it by itself, and it'll equal a negative number. If it was negative 7 times negative 7 would equal positive 49. That doesn't work. If it's positive 7 times positive 7, positive 49. That won't work. And there's no other way we can get to 49 other than 7s. So there's no square root of 49 other than a 7. That's the only number multiplied by itself to equal 49. So there's never ever going to be a square rooted instance where we're going to get a negative number. So when you're looking at number 2, what type of square root problem will never have an answer? It's whenever we have a negative number under the under the square root house. And you can call it a square root symbol, a square root house, whatever you'd like to call it. But anytime there's a negative number underneath that square root, it's an impossible answer. It's a null set answer. You can't do it. You can't multiply two numbers together that are the same number and have something be negative. However, negatives still do have a role when it comes to square roots. So if I gave you a problem that had a negative number under the house, this is impossible. Can't do it. However, there is a place where negatives still come into play, and that's when the negative is outside of the square root symbol. And so now if we think about this is almost like two-step problem. It's saying take the square root of 81 and then find the negative of it. So if I was ever doing something like this, first I would find the square root of 81, and that equals 9. And then I would take the negative of it, so negative 9. Now another way we could say that too is you could say, well, yeah, I know the square root of 81 could also equal negative 9. So if that was the case too, and then we were taking the negative of that, you could say then it's positive 9. So this gets really complex and complicated too when you think about the negatives outside. I will always look to prefer something and give you a direction whether I want that answer to be positive or negative. A lot of times you'll see this upper symbol and it might only mean it's a positive answer even though a negative is possible. So if we ever see a negative outside of a square root, we might have to do some things inside that square root to solve and then take the opposite. And so that's something where negatives can still have a role. It doesn't really pop up a ton, but if ever there's a case where it's outside of that square root symbol, then whatever you put for your answer, you can always just make opposite. So I think that gets you an answer to number 3. Just make your answer opposite. And number 4, we're talking about square roots of fractions. Square roots of fractions. If I have a fraction underneath a square root symbol, so maybe I have 25/64, or maybe I have the square root of 1/4. As we look through stuff like this, a lot of times people will think, well, yeah, I can take the fraction first, I can divide it out, then I can take the square root. That's totally true. However, there is a shortcut if both your numerator and your denominator are perfect squares, or even if they're not, you can still take square roots of them and keep them in fraction form. So really when you're looking through something like this, if I'm seeing this problem over here, the square root of 25/64, I know essentially I'm just going to take the square root of, I'll rewrite it here. The square root of 25/64 is the same as the square root of 25 over the square root of 64. It's going to get the exact same answer. So then I know the square root of 25 is 5. And I know the square root of 64 is 8. So then I could just write my answer as 5/8. Now, you could also know that it could be negative 5 and it could be negative 8. So it's never going to be a problem to just put that positive and negative symbol to show that both are possible. positive and negative 5/8 as a result for those, because negative 8 times negative 8 is 64, and negative 5 times negative 5 is 25. Both get answers for our square rooted numbers, so those are possible. Whenever we look at something like this too, remember that 1 is a perfect square. So this is the same as square root of 1 over square root of 4. It's really just taking the square root of the numerator and the denominator. Square root of 1, is equal to 1, and that could be positive or negative 1. And the square root of 4 is equal to 2, which could be positive or negative 2. Because 1 times 1 is 1, and 2 times 2 is 4, the square roots then kind of work opposite. So you take the square root of that answer. And so now I could almost say that an answer to this problem is simply positive or negative 1/2. And that's what I would put for a final answer. So whenever you're looking for something in number 4, how do you solve square root problems with a fraction under each? You take the root of the numerator and the root of the denominator, write it as a fraction. Lastly, you're going to see problems where roots are involved in equations. This is going to look something like x squared equals 25. And so the question is, what does x equal? What does x have to be? And we kind of saw this a little bit earlier, and it might be kind of intuitive too, because really what you're saying is, okay, well, I know that x squared is x times x, and I know that x has to equal 25, or x times x must be 25. The way to use this in an equation and a way to use a root is you could say, okay, well, then I know if I'm solving for x is the result of taking the square root of x squared. And so if that's what I really want, if I'm just taking the square root of this side in order to get to x, I just need to take the square root of the right side too. So now in order to solve for x, I just know that the x is equal to the square root of 25. I still need to solve that number, and so x is equal to 5 or negative 5, and both give me an answer that solidifies this problem. Negative 5 times negative 5 equals 25, and positive 5, let me just write on top here, positive 5 times positive 5 also equals 25. Both of those numbers give me solutions. So if we're ever seeing a problem that looks something like that, where you have m squared is equal to, let's go with 64. Then I could just really take the square root of both numbers, which in this case is just m, and then I could take the square root of 64. And if you weren't certain that this equals 8, remember on your calculator you can punch in square root and then type in 64, you hit equal, and you'll get that number. However, when we have perfect squares, I want us to get comfortable using our memory on some of these, because that's going to save us time in the very near future. So the answer to your final question, a problem listed as y squared is equal to 121, how do you use a root to get an answer? Well, you just take a square root of both sides of the equation, and then you find out what the square root equals, and there's your answer. Hope this video helps. Again, remember to attach your work to this first page, or that page of notes that I attached to this, and then your answers to this video and your book assignment is what you're going to turn into Canvas.